Hello and welcome. We're doing the Emperor's new formula. You can hear the Bunsen burner is going because I got a head start. So this is our unknown, beautiful blue color. And I got the mass. Figured you've already seen how to do that. And the reason it's this beautiful blue color is because it has water trapped in it. And so the gnome's over here running the Bunsen burner for us. Can you see the Bunsen burner? He's keeping an eye on it. And we're heating our sample. So let's see if we can see this. Oh, our sample's no longer blue. Because once the water leaves, it turns brown. It turns the color that I'm wearing. So the blue is when copper has water crystals trapped in it. When you have beautiful gems that we like to wear, whenever we see the colors, that's because water's trapped in there somewhere. So we're going to figure out how much water's trapped in there. And then we're going to figure out the ratio of the copper to the chloride. So we're going to heat it for another minute or two, get all the water out of there, and then we're going to let it cool. And so it turned brown. I'm going to pause you unless you want me to read the story to you. But the gnome, he's keeping a good eye on it for us. And he's not catching his knife on fire. Most important step. So I'll be right back. The mass again. Can you see? It pretty much looks like copper. Well, maybe not. It looks like sawdust because it's not copper. It's copper chloride. We just have to figure out the ratio of copper to chloride. So we're going to dump it in here. You can see it looks like sawdust. It is the color copper. And we're going to rinse with some water. Ready? What's going to happen when we add the water back? Why are we adding the water back? Look at that. It turned blue again. We're back where we started. It's kind of funky, but yeah, we're back to where we started. All right, let's just add, we're just adding, the amount of water we're adding doesn't matter at this point because we already drove off the water that was in the original compound. We're just adding water back so that we dissolve the copper and chloride. So the copper ion and the chloride ion are now in our solution, and we're going to put a piece of zinc in there. And you can see the zinc, which was this beautiful silvery color of zinc, is starting to change color. And we'll give it a few minutes. But let's go ahead and, well, let's talk about the reaction that's happening, because that's one of the lessons that we will be doing if we haven't done it already. So we have copper chloride. We just don't know what the X and the Y is. We'll be able to fill that in when you do your lab. So this is just getting the idea. And zinc is solid. So this is aqueous because we just dissolved it in the water. Now this part of the lab's done. This is for part B. So the reaction that's happening in part B is the zinc has a halo over it. If you've learned about oxidation reduction, it's perfectly balanced. Actually, we learned about the elements. This copper has a positive charge. We just don't know what the positive, and the chloride has a -1. So what's going to happen is the zinc, the copper wants zinc's electrons. The copper is missing an electron. It's either missing 1 or 2. So the copper is taking the electrons from the zinc and forming copper solid. And so we just have to give it a few moments to react. I don't know, can you see the copper chunks in there now? And our color's changing. It's getting murkier. It's turning to like a greenish blue instead of that brilliant blue. And over here, the zinc is combining with the chloride. Zinc likes to be a +2. And so we're doing the single exchange. Now we can't balance the equation and write the full equation until we know what this charge is. And that's what we're going to figure out once our reaction is complete. But yeah, you can see the color's disappearing. It's turning like this grayish murky, but I can still see some green there. So we're going to give it another moment or two. And then all that happens once we no longer see the green, I don't know if you can see, it's hard to see. Maybe not, without me dumping it on my computer. We'll add some, oh, the green looks like it's gone. We're going to add some HCl. The HCl helps to clarify it, and so what it does is it pulls out some of the stray ions that are there. Now, there is zinc left in there. There's a lot of copper and there's zinc. So let's go ahead and add HCl. And that's supposed to help to clarify it. And of course, it didn't quite clarify it. It's still pretty murky. It's definitely much better, but you can see there's quite a bit of copper. Really exciting. All right, there we go. It's clearing up. So we made copper. There is zinc in there, so I'm going to have to clean off my zinc and figure out how much zinc reacted. So just real quick, up here in part A, by doing subtraction, the mass loss is all H2O. Now, in this reaction, we're going to get the mass of the copper. We're also going to figure out the mass of the zinc that reacted, and then we're going to do a little stoichiometry and figure out what our percent yield is. So, all right, I'll be right back. All right, I'm back, and there's our copper. Doesn't it look beautiful? It is, and it looks just like copper. It is copper. You could technically make it into a wire. Sometimes we'll put it into a little bottle. People will take it home as a keepsake. I dried it under the heat lamp. A Rastafarian gnome is watching it for us. So, there's my final mass of the copper. And I did some calculations. And I'm going to tell you, so you know what you can figure out. Because you're going to have to analyze where my mistake is. The copper should have came out as a +2. So this ratio should end up as all 1, 1, 1, 1. Our formula should be written like this. And this is called copper 2. Remember, we put a Roman numeral because chloride's in the middle. So it's copper 2 chloride. But then we have to say, oh, there's 2, dihydrate. Couldn't remember the prefix for 2. So hydrate means there were 2 water molecules trapped in there. Now, my numbers are not going to come out perfectly. This is going to give you the mass of the water. This is our mass of our copper. So how do we find the mass of the chloride? Well, this is the mass of just the copper and the chloride, and if we subtract out the copper, that will give us our chloride. So I actually get okay numbers. I get numbers like you guys would have gotten. So using our sig fig rules, you're going to keep 3 sig figs through everything. You're not going to get a perfect ratio. I lost some copper. Some of the copper was stuck to the filter paper, and that's okay. That's probably was our biggest mistake. Or maybe my water wasn't fully dehydrated out of it. It sure looked like sawdust, so it looked like all the water was gone. I don't know. There's lots of places that things can go wrong. And it's okay. You don't have to be perfect all the time. You don't have to be uber perfect and have 105%. All right. So you get to do the number crunching. Do some post-lab analysis of where me and my friendly gnomes may have lost some of our copper. And I'll see you next time. Bye.